The foundation wasn't sinking. That would imply it was moving downward uniformly. Building 87, park next door, was sinking. Millennium Tower in San Francisco was sinking. Champlain Towers South was differentially settling, tilting, and experiencing punching shear failure at multiple column locations simultaneously. There's a difference, and that difference killed 98 people. 3 engineers knew. The condo board knew. The town's building inspector had the 2018 report on file. No one used the word evacuate. They used the word assess. But before we understand why assessment became a death sentence, we need to go back to 1993, when the first cracks appeared in the parking garage. Meanwhile, the pool deck was already collecting water, in ways the architect never intended. What happened over the next 28 years would rewrite how engineers think about concrete deterioration in coastal buildings. This is the story of how a building told everyone it was dying, and why no one listened until it was too late. Champlain Towers South stood at 8,777. Collins Avenue in Surfside, Florida, 12 stories, 136 residential units, built in 1981 by developer Nathan Reiber and designed by architect William Friedman, working with structural engineer Breiteman Gerardo and Associates. The building occupied a narrow lot, just 150 feet wide, squeezed between the Atlantic Ocean to the east and Collins Avenue to the west. From the beach, it looked like dozens of other Miami area condominiums. White concrete, blue glass balconies, nothing special. What made it unique was invisible. The entire structure sat on a reinforced concrete mat foundation, a massive slab designed to distribute the building's weight across soil that geologists knew was problematic. The water table sat just inches below ground level. Salt water, constantly moving, always hungry. The original engineering calculations assumed several critical factors: the concrete cover over the rebar, the steel reinforcement bars, would remain at 4.5 inches minimum. The waterproofing membrane on the pool deck and parking garage would be maintained and replaced every 15 to 20 years. The building would be inspected regularly. None of these assumptions survived contact with reality. Instead, from the moment the first residents moved in during 1981, the building began a slow process of chemical transformation. Salt water, whether from the ocean spray, the pool deck, or the rising water table, began infiltrating the concrete. Meanwhile, the chloride ions in that salt water were searching for steel. When they found it, the corrosion process was irreversible. Here's what happens at the molecular level, and understanding this is essential to understanding why 98 people died. Chloride ions penetrate concrete through capillary action and diffusion. When they reach the steel rebar, they break down the passive oxide layer that normally protects the steel from corrosion. Once that protection is gone, the steel begins to rust. But rusting steel doesn't just weaken, it expands. Iron oxide occupies approximately 7 times the volume of the original steel. This expansion creates internal pressure inside the concrete, measured in thousands of pounds per square inch. The concrete, strong in compression but weak in tension, begins to crack. Those cracks allow more salt water to enter, more chloride ions reach more steel. The corrosion accelerates. The expansion increases. More cracks appear. the cycle feeds itself. Engineers call this chloride-induced corrosion. Residents called it spalling when chunks of concrete fell off the garage ceiling. What they should have called it was a countdown. The pool deck design contained a flaw that wouldn't become obvious for decades. William Friedman, the architect, specified a pool deck that was nearly flat, with minimal slope for drainage. The structural engineer designed it as a reinforced concrete slab supported by columns, standard construction for 1981. But then came the critical decision. The pool deck was built at ground level, directly above the parking garage. The waterproofing membrane, a rubberized layer meant to prevent water from reaching the structural concrete below, was installed on top of the structural slab. This meant the concrete itself sat in constant contact with whatever moisture accumulated underneath. The drainage system relied on gravity and a series of drains placed around the deck perimeter. The slope was minimal, less than 1% in most areas. During heavy rain, which Miami receives approximately 60 inches of annually, water would pond on the deck surface. Meanwhile, underground, the water table was rising. Studies conducted by Florida International University's Sea Level Solutions Center would later show that the Surfside area experienced rising groundwater levels beginning in the early 2000s. The water table, which had been 18 to 24 inches below grade in 1981, was now often less than 12 inches below the surface. The parking garage, built partially below grade, was essentially sitting in a bathtub of saltwater saturated soil. The concrete floor slab, the walls, and the columns were all in constant contact with chloride-rich groundwater. But the pool deck above them had an even more insidious problem. Water that ponded on the pool deck surface couldn't drain properly. Instead, it would sit for hours, sometimes days, after heavy rains. That water would slowly infiltrate through the concrete, carrying chloride ions with it. By the time it reached the rebar, the chloride concentration was high enough to initiate corrosion almost immediately. The original design called for 4.5 inches of concrete cover over the pool deck rebar. Core samples taken from the rubble in 2021 would later show that actual cover depths were significantly less than specified. In many areas, the concrete cover had degraded substantially. This wasn't simply a construction error. As the rebar corroded and expanded, it pushed the concrete cover upward and outward. Eventually, that cover would crack and spall off, exposing the rebar directly to the air and water. But before we see how this played out, we need to understand who was supposed to be watching for these problems, and what they did when they found them. October 9th, 2018. Frank Morabito, a structural engineer with Morabito Consultants, delivered a report to the Champlain Towers South Condominium Association. The report ran 95 pages, including photographs, structural calculations, and recommendations. The executive summary used the phrase major structural damage 9 times. It described abundant cracking and spalling in the concrete columns, beams, and walls of the parking garage and pool deck. It noted that the waterproofing below the pool deck and entrance drive was beyond its useful life, and therefore must be completely removed and replaced. The estimated cost for repairs, $9.1 million. Meanwhile, residents had been complaining about concrete falling from the parking garage ceiling for years. Some had photographed the damage. One resident, Mara Chuela, who lived in Unit 411, had sent multiple emails to the condo board describing chunks of concrete falling onto parked cars. The board's response was consistent. They were aware of the issues and had hired engineers to assess them. Assessment, they explained, takes time. Repairs would be expensive. They needed to plan carefully. But then came a detail that would later prove crucial. Morabito's report specifically noted that the failed waterproofing is causing major structural damage to the concrete structural slab below these areas. This wasn't cosmetic damage. This was structural failure in progress. The report recommended immediate action. Though some of this damage is minor, most of the concrete deterioration needs to be repaired in a semi-timely fashion. It noted that failure to do so would cause the concrete deterioration to expand exponentially. The condo board filed the report. They began the process of obtaining bids for the repair work. They scheduled meetings. They discussed financing options. What they didn't do was evacuate the building. Instead, the repair work was delayed. First, by the need to coordinate with the town of Surfside's mandatory 40-year recertification process. Then by disagreements over the scope of work. Then by the COVID-19 pandemic. Then by concerns about special assessments and their impact on property values. By April 2021, 30 months after Morabito's report, the repair work still hadn't begun. Meanwhile, the building continued to deteriorate. The chloride-induced corrosion didn't pause for committee meetings. The expanding rebar didn't wait for budget approvals. The cracks kept growing. A new engineering firm, Alan Kilsheimer of KCE Structural Engineers, would later examine the debris and reach a devastating conclusion. The building's structural integrity had been compromised for years before the collapse. Multiple columns showed signs of advanced corrosion. The pool deck slab had lost significant load-bearing capacity. The punching shear capacity at several critical column connections had degraded below minimum safe thresholds. But in April 2021, no one was measuring punching shear capacity. They were scheduling meetings. The building was moving. Not dramatically, not in ways visible to the human eye, but moving nonetheless. Researchers at Florida International University, led by Dr. Szymon Wodawinski, had been using satellite-based interferometric synthetic aperture radar, known as INSAR, to measure ground subsidence throughout South Florida. INSAR works by comparing satellite images taken months or years apart, measuring changes in elevation with millimeter precision. In 2020, Dr. Wodawinski published data showing that Champlain Towers South had subsided approximately 2 millimeters between 1993 and 1999. 2 millimeters doesn't sound significant. It's less than 1/10 of an inch. But then came the critical comparison. Normal settlement for a concrete building on competent soil is approximately 1 millimeter per decade. Champlain Towers South had settled 2 millimeters in 6 years. That's more than 3 times the expected rate. Meanwhile, the building next door, Champlain Towers North, showed different settlement patterns. It was moving, but uniformly. The entire structure was settling at roughly the same rate. Champlain Towers South, however, showed differential settlement. Different parts of the building were moving at different rates. This meant the structure was bending, ever so slightly. Concrete doesn't bend gracefully. When it bends, it cracks. The satellite data couldn't tell engineers where the cracks were forming. It couldn't identify which columns were experiencing the most stress. But it could tell them something was wrong. The building's foundation wasn't behaving normally. Instead of publishing this data as an immediate warning, Dr. Dewodowinski included it in a broader study of subsidence patterns throughout coastal Miami-Dade County. The study was peer-reviewed. It was published in academic journals. It was available to anyone who looked for it. No one from Champlain Towers South looked for it. The condo board was focused on the visible damage in the parking garage. The town's building department was focused on the 40-year recertification process. The engineers were focused on preparing repair specifications. The satellite data sat in academic publications, showing that the building was moving in ways that suggested structural distress. But then, academic publications don't trigger evacuations. Building officials don't routinely review subsidence studies. And condo boards don't have geotechnical engineers on retainer. What the satellite data proved, in retrospect, was that the building had been telegraphing its distress for decades. The ground beneath it was shifting. The foundation was responding. The structure was bending. All in slow motion. All measurable. All ignored. The parking garage told the clearest story, if anyone had been reading it. Residents walked through it daily. They parked their cars under concrete ceilings that showed obvious signs of distress. Spalling, the technical term for concrete falling away from rebar, was visible throughout the garage. In some areas, the rebar was completely exposed, showing orange-brown rust stains. Multiple residents had documented the garage deterioration. They photographed cracks in the columns. They reported standing water that pooled near certain columns. They noted areas where the concrete appeared damaged. Their communications to the condo board expressed growing concern about the building's condition. When would repairs begin? Was the building safe? The board's responses followed a pattern: acknowledgement, reassurance, delay. Yes, they were aware. Yes, they had hired engineers. Yes, repairs were planned. No immediate danger was indicated. Meanwhile, other residents reported symptoms of structural distress. Doors that suddenly wouldn't close properly, cracks appearing in walls, visible damage to the pool deck surface. But then came the final weeks before the collapse. Multiple residents had reported concerns about the pool deck area. Some noticed standing water that wouldn't drain properly. Others observed new cracks appearing in the parking garage. Punching shear failure. The words sound technical, abstract, academic. But understanding this failure mode is essential to understanding why the building came down in seconds. In a flat slab concrete structure, like Champlain Towers South, the floors and deck slabs are supported directly by columns without intermediate beams. This creates a clean, open architectural space, but it also creates a structural vulnerability. The slab must transfer all its load, everything it's carrying, into the column through a relatively small area. This creates enormous shear stresses in the concrete surrounding the column. Imagine pushing a pencil through a sheet of paper. That's punching shear. The column punches through the slab. Engineers design against this by ensuring the concrete around each column is thick enough, strong enough, and properly reinforced with steel. The calculations involve complex formulas that consider the slab thickness, the concrete strength, the column size, and the amount of load being transferred. For Champlain Towers South, the original calculations showed adequate punching shear capacity throughout the structure. The pool deck slab was 9.5 inches thick. The parking garage ceiling was 9 inches thick. Both specifications met 1981 building code requirements. But those calculations assumed the concrete, would maintain its designed strength. They assumed the rebar wouldn't corrode. They assumed the waterproofing would be maintained. Meanwhile, 40 years of chloride intrusion had fundamentally altered the concrete's properties. Corroded rebar loses its bond strength with the surrounding concrete. It can't transfer loads effectively. When rebar expands from corrosion, it creates internal cracks that weaken the concrete matrix. The effective thickness of the slab, the part that can actually carry load, decreases. By June 2021, forensic engineers would later calculate that several columns in the pool deck area were operating at or beyond their punching shear capacity. The slabs around these columns were held up by concrete that was cracked, weakened, and barely clinging to corroded steel reinforcement. The structure was in a state of precarious equilibrium. Any additional load, any shock, any redistribution of stress could trigger failure. And once one column failed, the loads it was carrying would have to go somewhere. They would transfer to adjacent columns. Those columns, already stressed, would also be pushed beyond capacity. This is called progressive collapse. One failure leads to another, then another. The sequence accelerates. Within seconds, a localized failure can bring down an entire structure. But then, progressive collapse requires an initiating event, something that pushes the first critical element past its capacity. At Champlain Towers South, that initiating event was likely the pool deck. June 24th, 2021. 1:13 a.m. Eastern Daylight Time. The pool deck collapsed first. Not the building. The deck. A witness in the adjacent building, Shamoka Furman, was on her balcony when she heard what she described as a strange creaking sound like metal bending. She looked toward Champlain Towers South and saw the pool deck area suddenly drop. Dust exploded upward. The crash echoed between the buildings. She immediately called 911. Her call was logged at 1:14 a.m. She reported that the pool deck and part of the parking garage had collapsed. She couldn't see anyone in the debris. She didn't know if anyone was injured. Meanwhile, inside Champlain Towers South, residents in the still standing portion felt the impact. Doors rattled, pictures fell from walls. Some residents later reported hearing what sounded like thunder or an explosion. Residents in units overlooking the pool deck area could see that the deck had collapsed. Where the pool and deck had been, there was now a crater filled with concrete rubble. Cars in the parking garage below were now exposed to the night sky. Some residents reached for their phones to call for help. They didn't have time. At 1:22 a.m., 8 minutes after the pool deck collapse, the central section of Champlain Towers South's main building came down. 136 units, 98 people, 12 stories of concrete and steel. The collapse took approximately 12 seconds. Security camera footage from a neighboring building captured it. The building didn't tip or lean. It didn't fall sideways. It collapsed vertically, pancaking down on itself, each floor falling onto the one below, the weight accelerating with each impact. The sound woke residents for miles. People reported feeling the ground shake. Windows rattled in buildings blocks away. A massive dust cloud, visible on security cameras, exploded outward and upward, enveloping Collins Avenue. By 1:23 a.m., the collapse was complete. What had been a 12-story condominium building was now a pile of rubble, roughly 4 stories high. The southern section of the building, containing units at the south end, remained standing, sheared cleanly. Interior walls exposed. Furniture visible in rooms that now opened directly to the night air. But then came the question that would haunt investigators, survivors, and the families of victims for years. Why? What specifically caused the initiating failure? Was it the pool deck, a column, the foundation, and more importantly, why didn't the building show more obvious warning signs? The rescue operation began within minutes. Surfside Fire Rescue, already responding to the pool deck collapse, pivoted immediately to the much larger catastrophe. Additional units from Miami-Dade Fire Rescue, Miami Beach Fire Rescue, and surrounding municipalities arrived within 15 minutes. The scene was chaotic. The dust hadn't settled. Fires had broken out in the rubble, fed by severed gas lines. Water from broken pipes was flooding the basement levels. The portion of the building still standing loomed over the debris pile, visibly unstable. Instead of attempting a traditional rescue operation, teams had to proceed with extreme caution. Every step could trigger additional collapse. Every piece of debris they moved could destabilize the pile. The still standing portion could come down at any moment. Rescue workers used sound-detecting equipment, searching for survivors. They would work in pairs, moving carefully through the debris, calling out, listening. In the first hours, they heard responses. People were alive in the rubble. Meanwhile, structural engineers were arriving to assess the stability of the remaining building section. The question wasn't if it would collapse, but when. Large cracks were visible in the exposed columns. The structure was essentially hanging from its moment connections, the steel reinforcement between columns and slabs. Those connections were never designed to support the building in this configuration. Over the next 2 weeks, rescue teams worked 24-hour shifts. They cut through concrete with specialized saws. They shored up unstable sections with timber cribbing. They worked through tropical storm weather, through structural collapses within the debris pile, through the grim reality that became apparent within days. This was no longer a rescue operation. It was recovery. A small number of survivors were pulled from the rubble in the first hours after the collapse. After the first day, recovery efforts focused on locating and identifying victims. 98 people killed. The deadliest structural collapse in United States history, outside of the September 11 attacks. More than the Hyatt Regency Walkway collapse. More than the I-35 bridge in Minneapolis. More than any other residential building failure in American history. On July 4th, 2021, the remaining portion of Champlain Towers South was demolished using controlled explosives. Structural engineers had determined it was too unstable to leave standing. The demolition brought down what the building's own structural failure had left behind. The National Institute of Standards and Technology, NIST, began its investigation on June 30th, 2021. The same agency that investigated the World Trade Center collapse and the Station nightclub fire now turned its attention to a condominium building in South Florida. NIST investigations are exhaustive. They collect every available piece of evidence: security camera footage, maintenance records, design drawings, construction photos, weather data, eyewitness testimonies, material samples from the debris. The team began by creating a 3-dimensional computer model of the building as it existed on June 24th. Every column, every slab, every beam. They input data from the original design drawings, modified by information from inspection reports showing concrete deterioration. Meanwhile, forensic engineers were examining pieces of concrete and rebar pulled from the debris. They measured chloride concentrations. They tested concrete strength. They examined the bond between steel and concrete. They photographed corrosion patterns. What they found confirmed the worst suspicions. Chloride concentrations in samples taken from the pool deck and parking garage significantly exceeded accepted corrosion thresholds. Some rebar samples showed severe section loss, the technical term for steel that had corroded away. In engineering terms, many of these bars had lost substantial strength. The concrete itself had deteriorated significantly. Compression tests showed strengths well below the original design specifications. But then came the critical question: which element failed first? Did the pool deck collapse trigger the building collapse? Did a column fail, causing both the deck and building to come down? Or did multiple elements fail nearly simultaneously? NIST's preliminary findings, released in phases over the following years, pointed to a likely sequence. The pool deck slab in the area near the building's southern perimeter wall failed first, likely due to punching shear failure at one or more column locations. This sudden loss of the deck slab removed lateral support from several columns in the building's pool deck level. Those columns, already weakened by corrosion and now lacking the bracing provided by the slab, became unstable. When they failed, they triggered the progressive collapse of the building's central section. The failure propagated upward and outward in a matter of seconds. Computer simulations run by NIST researchers showed that once the pool deck collapsed, the building had less than 10 minutes before the progressive collapse became inevitable. In reality, it had 8 bold minutes. The question everyone asked afterward was simple and terrible. How did this happen in America? How does a building in a major metropolitan area, subject to building codes and inspections, simply collapse without warning? The answer, investigators found, was that the warning signs were everywhere. They just weren't being interpreted correctly, or at all. Morabito's 2018 report had documented major structural damage, but the term major structural damage doesn't automatically trigger evacuation protocols. It triggers repair processes, engineering assessments, budget discussions. The language of the report, while technically accurate, didn't convey the urgency that the situation demanded. Meanwhile, the town's building inspection process focused primarily on life safety systems, fire alarms, elevators, emergency lighting. The 40-year recertification process did require structural assessment, but it was designed to identify needed repairs, not to evaluate whether the building was safe for occupancy during the repair planning phase. Florida has since changed its laws. Buildings older than 30 years in coastal areas must undergo more rigorous structural inspections. Engineers must explicitly state whether a building is safe for continued occupancy. Building officials have been given authority to order immediate evacuations if structural integrity is questioned. Other states have begun similar reviews. California, facing its own aging concrete infrastructure, has implemented enhanced inspection requirements for buildings in seismic zones. New York City has expanded its facade inspection program to include structural elements. But then came the harder question: how many other buildings are out there with similar problems? How many concrete structures built in the 1970s and 80s are experiencing chloride-induced corrosion? How many pool decks are sitting on deteriorated slabs? How many parking garages have exposed rusted rebar? Studies conducted after the Surfside collapse have found that a significant percentage of concrete structures built before 1990 in coastal areas show signs of chloride intrusion. Not all are in danger of collapse, but all require assessment. The engineering community has responded by developing new inspection protocols specifically for chloride-induced corrosion. Ground-penetrating radar can detect voids in concrete caused by rebar corrosion. Half-cell potential testing can identify areas where corrosion is active. Core sampling can measure actual chloride concentrations at rebar depth. These technologies existed before Surfside. They weren't being systematically applied to existing buildings. Now they are. Insurance companies have also responded. Premiums for older concrete buildings in coastal areas have increased dramatically. Some buildings are being deemed uninsurable without comprehensive structural assessments and proof of adequate maintenance. The financial implications are significant. Studies have estimated that bringing at-risk concrete structures in Florida up to current safety standards would require tens of billions of dollars in investment. Nobody has that money. But not spending it means more buildings will fail. Meanwhile, survivors and victims' families continue dealing with the aftermath. Litigation is ongoing. Multiple parties have been named in lawsuits: the condo association, the engineering firms, the town of Surfside, contractors who worked on the building. Settlement amounts are expected to be substantial. Insurance policies are being exhausted, but no amount of money brings back 98 people. The building told everyone it was dying. The cracks in the garage, the spalling concrete, the engineering reports, the satellite data showing subsidence, the ponding water on the pool deck, multiple warning signs that residents had reported. Every single one of these was a symptom of advanced structural distress. Taken together, they painted a clear picture of a building in critical condition. But instead of emergency response, they triggered committee meetings, budget discussions, repair planning, assessment schedules, the condo board meeting. Minutes from 2018 through June 2021 document extensive discussion of assessments, repairs, and engineering studies. But the focus remained on planning and preparation, not on whether the building was safe for occupancy during that planning phase. Meanwhile, the engineering profession has had to confront an uncomfortable truth. Technical accuracy isn't enough. Morabito's report was technically correct. It documented the damage, it recommended repairs, it explained the consequences of delay. But it didn't say, "This building is unsafe for occupancy." It didn't say, "People need to leave now." Whether it should have said those things is now the subject of intense debate in engineering circles. Should engineers err on the side of caution and recommend evacuation for any serious structural issue? Or does that level of conservatism lead to unnecessary evacuations, property devaluation, and economic disruption? There's no easy answer. But then, 98 people died because everyone chose the path that seemed reasonable at the time: assessment instead of evacuation, planning instead of action, tomorrow instead of today. The families of those 98 people would make a different choice. Everyone involved in the building's management would make a different choice. Even the building inspectors and town officials who followed standard procedures would make a different choice. But in June 2021, with the information available, with the pressures they faced, With the systems they operated within, they made the choices they made. Assessment seemed reasonable. Planning seemed prudent. Delaying expensive repairs until absolutely necessary seemed financially responsible. The building disagreed. At 1:22 a.m. on June 24th, it delivered its final assessment. Not with a report, not with a recommendation, with 12 seconds of catastrophic structural failure that killed 98 people and changed how America thinks about concrete buildings. The satellite data showed it was sinking. The engineering reports documented the damage. The residents reported the symptoms. The pool deck was failing. The columns were corroding. The concrete was cracking. Everyone knew, but no one evacuated. And that's the difference between structural failure and catastrophic tragedy. The building was going to fail regardless. Engineering can predict that. What engineering couldn't predict was the human decision to let people remain inside while it happened. That decision, documented in meeting minutes, email threads, and budget proposals, is the real story of Champlain Towers South. Not the chloride-induced corrosion, not the punching shear failure, not the progressive collapse. Those are technical explanations for how the building failed. The real explanation for why 98 people died is simpler and more damning. They knew it was failing, and they chose assessment over evacuation. Okay.